So far so good. Congratulations for all of you that survived until this time. I think that maybe it will mean something, I don't know what. And me too also, I don't know what. I was just also now not so sure about which file I had to open. And so that is just the last lecture in this series. And so thank you very much for you for being here up to now. Thank you all for some new students that I'm very happy to see in the room. And I'm very serious in this regard. I'm very grateful also for this presence. We put in this last lecture this topic just because, okay, for several reasons. I don't know if maybe this kind of topic should have been treated in advance, but I think that so far in the last few days, and even today in the morning, and yesterday, and a couple of days ago, you heard a lot about parameters, quantitative parameters, which are used to evaluate scientific journals in particular, papers. This morning we just heard about how to choose a journal in which to publish, and you heard a lot about impact factor, about citations, and something like this. And so I think it's important to have some basic knowledge also about this issue of bibliometrics. But first, from the position in which we put this topic, and second, also maybe from the title of the lecture which I choose, maybe you will understand. And in this regard, I would like to declare what maybe I will not call my conflict of interest, but my position, which maybe I can say is biased towards a few criticism in regard to this very heavy use of citation analysis for the evaluation of research. This is the point. And so I will just provide you with some basic definitions on what is bibliometrics and which kind of parameters are used, which is the basis for the use of these parameters for the evaluation of journals, for the evaluation of researchers. And I hope that I will be able to be clear also about limitations of this kind of and possible additional biases that we pose when we use this kind of approach. And so this will be the several points which I will treat. I don't want that you will be scared by the number of these points. I hope that I will succeed in being brief for all of these points. But first of all, I mean, which is the origin of this, let's call science, or at least this area of research, this discipline? I mean, bibliometrics, what it is and what it was made for. So some history, because the history is quite recent, but from my point of view, it's very interesting. I mean, historically, bibliometric methods have been used to trace relationships amongst academic journal citations. Just relationships among academic journal citations. Citation analysis involves examining an item's referring documents and is used for searching for material and analyzing their merit. I will show you now the original use of this kind of approach, that is citation analysis, so the quantitative analysis of citations of what we put in bibliographic references in our papers, in our books, and so on. I'm sorry. Of course, citation analysis is a very important discipline. Citation analysis and content analysis. We will not speak about analysis of the text of articles and books, but these are commonly used bibliometric methods, most often used in the field of library and information science. So it's actually a very important discipline, area of research, which provides very useful models and techniques. The point is that now, and over and over, much more and more in these last few years, many research fields use bibliometric methods to explore the impact of their field, the impact of a set of researchers, the impact of a particular paper or also the impact of an individual researcher. And so maybe it's possible to understand also why we now, step by step, we have more and more conditions to have this kind of approach, this quantitative evaluation of research. Maybe just because, this is a slide that I already showed you, just because the output of research in terms of publication is steeply, very strongly increasing. There is an exponential increase in the number of papers which are published each year, and also this is a slide that I already showed you, just to tell you again that according, for instance, to a recent study which was published last year, again from the group of John Ioannidis, we have about, just in the biomedical field, I mean, in about, let's say, 15 years, about 25 million papers. So, of course, it's very much, and it's possible that people will try to find some way to not to be forced to read all these papers. This is the point, of course. But in any case, we must be very careful, because it's not possible, of course. Maybe this is just already my take-home message of this lecture. We should not be conditioned to use just bibliometric analysis to evaluate a paper, and so just to use bibliometric analysis instead of reading a paper, of reading the output of a researcher, which is the only true and I maybe think honest method to honestly evaluate the activity of a researcher, the activity of a group, or the quality of the output of research. So this is the man to which all of us are indebted also for the existence of this lecture and for this course not yet finished, because this Eugene Garfield, he's still alive, so if any one of you would like to tell him something about it, you can do it. He is one of the main persons who are responsible for the modern bibliometric and scientometric science. And of course, he was and he is a brilliant researcher who introduced, I mean, the basic methods of the modern bibliometric science, which was also, and is also very useful. Yesterday, you heard about how to use some of the main databases which are used for bibliometrics, which use also are mainly based on citation analysis, just to find relevant papers which can be used for your as references for your research, for meta-analysis, but also as a basis for your research. So it's very important. I mean, for instance, classical databases allow research backwards, but citation analysis allows the research of papers which are relevant to a defined topic prospectively. So, for instance, if you have a paper, I mean, a very, I think, appropriate use of this kind of databases which use citation analysis. If you have a paper that you think it's very significant, relevant for the research that you would like to perform, for the field in which you are interested in, and would like to know not only what happened before that paper, but which kind of work was done after this paper, just to know now which is the state of the art, which are all the other studies which were performed based on that same study. Of course, you can use citation analysis, that is just to look at the papers which, after the publication of that study, use that study in their references. This is actually maybe a very correct approach to. This is just some historical examples of the use of citation analysis, in particular for the purposes of for instance, of the librarian sciences. The first one on the upper part of the slide is just an example of a bibliometric study ante litteram, because it's a paper in 1927 in which these people just looked at papers or journals which were cited in a definite issue of the Journal of the American Chemical Society, just which was at the time, and still is a very important journal in the field of chemistry, just to identify which were the relevant journal in the field of chemistry with the purpose to develop a list of journals which should have been subscribed by librarians to provide researchers into a definite institution with the main relevant bibliographic references. I don't know if I was clear in this regard. And the same, this is a more modern example. It's a recent paper, 2005, but it's one of the many examples in the librarian field. The same, this is an analysis, a citation analysis, but I mean, it's just librarians that did an analysis of the journals in which the researchers in that same institution, California State University in Camarillo, the journals in which the researchers in that institutions were publishing, and the journals that were included by those researchers in that institution in the references of their papers. So just to be sure, I mean, for just for planning purposes, just to be sure that that library could provide the researchers of that institution the most appropriate subscriptions to the journals. Of course, just to be sure that, or to be confident that the few money that is available for subscriptions is just used in the most appropriate way. So it's a very fair use of citation analysis. Which are the most relevant, the most important databases? You already heard about this. It's a web of knowledge, which is an evolution just directly coming from the work of Eugene Garfield. It's also Scopus. It's another database which was more recently developed by Elsevier, and about Google Scholar we heard. It's not my purpose to go through the detailed definition of the pros and cons of all these databases. I just tell you that there is a recent paper, that is this one in PASEP Journal in 2008, which exactly does a comparison of the main databases which can be available for biomedical research, including also PubMed. And so you can see all the facilities and also maybe the shortcomings which all these databases may have when you use them. But what citation analysis became when it began to be used for the purpose of evaluating the quality of science, which, again, as I told you, in my opinion, is a kind of potential, I don't want to say maybe through degeneration, but brings with it a lot of risks which need to be aware of. So the definition of the various parameters which are used in this regard. First of all, the impact factor. We already spoke about impact factor. You heard that a lot of people just showed you that the impact factor is one of the main factors that is used to assess the quality of research, and in particular the quality of scientific journals. So what is the impact factor? This is in red the definition. The impact factor of a journal is calculated for a given year in terms of the average number of citations received per paper published in the journal during the 2 preceding years. Clear the definition? So you just take the papers that were published in the journal in the 2 previous years as a denominator of the fraction, and you put in the numerator the number of citations that were obtained. So apparently it's very simple, and it looks apparently maybe very nice. It's possible to say, okay, do those papers had actually an impact? I mean, did they drive the attention of people? But of course, okay, which are the limits of validity? You need to think about this, and several lectures, including I think also this afternoon, the lecture by Daniele Fanelli showed you, for instance, that the number of citations is highly discipline dependent. So please be very careful about comparing, also in the biomedical field. I mean, discipline dependent. It means, for instance, that the average number of citations of references that we put in papers is highly variable between, for instance, also different areas of medicine or different areas of biology. I mean, so you cannot compare, for instance, but we spoke a lot about this. But most interesting, the impact factor, maybe it's not reproducible itself. I will show you some example in this regard. It cannot be independently reproduced. This is just apparently a few disturbing, I mean. The impact factor refers to the average numbers of citation per papers, but speaking a few statistically, the average, it means that we imply a normal distribution of citations, so that we have very highly cited papers, very highly cited papers which are cited maybe a few or nearly nothing, and the chord, the most, I mean, a Gaussian distribution. But this is not the case. This is not the case, since there are several studies, and also one seminal study a few years ago, which provided material for a lot of discussion and concern, just showing that a few papers, usually even in very top-level journals like Nature, only a few papers provide the most part of the citations. And most of the papers usually collect few or no citations, at least in the 2 years in which, by convention, the impact factor is calculated. In the short term, especially in the case of impact journal, there is a lot of influence by self-citations. Of course, if you know that it's important to cite your work, so you should be the first one that cite your work, why not? Those databases also allow to purify, to clear your self-citations, but in any case, this is another source of bias. And journal ranking lists constructed based on the impact factor, only, there are some studies in this regard, only moderately correlate with journal ranking lists based on the results of an expert survey. So I mean, the perceived quality of this, of course, besides top-level journals, which everyone would agree about, but most part of the journals we have a lot of journals, and in a given discipline, the impact factor is not so sensitive. In particular, I mean, average values of impact factor are not so sensitive as to discriminate between the quality of the perceived quality of journal, the quality perceived by experts in the field. We heard about a lot of strategies which can explicitly affect the impact factor, and I can reassure you about the fact that publishers, and in particular editors, are very well not only aware of all these techniques, but they would like voluntarily to apply these techniques to increase the impact factor of a journal. Why to increase? To attract papers. Now, this is out of the scope of this presentation and also of this course, but I would like that maybe in future we will also deal maybe with the business which is now become the scientific publishing. No one knows exactly about this. I don't know, maybe in future we need to also to deal with this topic, but someone estimated in a few studies, not possible to have clear figures, but estimated that annually the total business of scientific publications has been estimated in about between 15 and $20 billion per year. I mean, 15 and 20 billion, not million, billion. And of course, there are multinational enterprises which own the lion's share of this business. It's a little bit maybe like in big pharma, I would like to say. You know, when you hear about Elsevier, when you hear about Springer, when you hear about Wiley, Elsevier, Springer, and Wiley, and you have already about 75–80% of the whole scientific business worldwide. But this is out of the scope. Just again, just back on editorial policies that affect the impact factor. You heard about the possibility that a given kind of papers will attract more citations. You heard about review papers. You heard about papers dealing with clinical trials. Also because the clinical trials can be supported by pharmaceutical industry, and then pharmaceutical industry is interested in dissemination, and so there is dissemination bias, which affects specifically these trials. But I would like to spend a couple of minutes more about another strategy, which has been highlighted a few in some previous lectures. Journals, as I told you, the fraction for the impact factor, citations, and number of items published in the previous 2 years. But both the numerator of the fraction usually is always the total number of citations of any item. The denominator in particular, this is a matter of agreement between the journal and the society which calculates the impact factor. This I forgot to tell you. So the impact factor is not just a measure that anyone can calculate in public databases. The impact factor, I think that it's a trademark. But in any case, it is registered with a copyright and the trademark. And there is only the official impact factor. You can find some journals which provide you with an unofficial impact factor. Unofficial. What does it mean? That they were not yet accepted by Thomson Reuters, the Easy Web of Science. It's a trademark by Thomson, which is the biggest at present multi-enterprise in the field of scientific publishing, and not only this field. So they calculate the impact factor in their own databases, which are not publicly available, and on which it's not possible to do, for instance, independent audits. I will show you an example later. And this Thomson makes a specific agreement with each journal, and this agreement is just secret. No one can know about this agreement. And journals just agree about which kind of items will be taken into account to calculate the impact factor. So maybe you heard about when Professor Ageno told you, for instance, that you can have a paper maybe not accepted as, let's say, full research paper, but maybe the editor says, okay, this paper is fine, but I can take this paper maybe as a letter. I can take this paper as a short report. Maybe also because, and Professor Ageno told you, just because in this way the editor-in-chief is not so much worried about how many citations this paper can obtain in the next couple of years, just because this is not part of the denominator. So, okay, you can publish, maybe because this paper was fine. I know that it's not so fashionable, but please go on. So, I mean, just remember. Another strategy, another described strategy, 2 years that these papers will be cited, the window of opportunity to increase the impact factor. So, for instance, you think that you have a very nice paper that will attract attention. So, first of all, just select papers that will attract attention. And second, try to publish them in advance, maybe in the January issue. And just in the December issue of the second year, the papers that you think will be not so relevant. No one yet thought about the possibility to look at some differential profile for papers which are published in January in comparison to papers which are published in December. But I mean that maybe this makes sense in this light. It's possible also some active manipulations, but it's just an anecdotal report, incredible, and I will skip very quickly about this. Maybe just this is a suggestion that you can take into account. The second example, it's a paper which was, it's a review paper which was published in a journal in the field of chemistry, Acta Cristallographica. And it's interesting because this is a kind of review paper which used this sentence. This paper could serve as a general literature citation when you deal with this topic. And this paper received very quickly thousands of citations. Maybe just the hypothesis that it may be just because there was some suggestion. And so when people were just hacking the bibliographic databases in search for some reference that it's possible to put in the introduction of your manuscript and say, which kind of general reference can I find? Ah, okay, maybe this is a good suggestion. And of course, thousands of citations very quickly. And the impact factor of this journal, which was about 2, rise to more than the impact factor of Nature, of the New England Journal of Medicine, etc. So, I mean, need to be careful about this, but this is just macroscopic variations that is possible to understand. But so, just to know, the main incorrect application, but I think that now it is clear based upon all the things that we heard during these days, the impact factor, maybe it's a gross measure of the quality of the journal, maybe, but of course, please do not use the impact factor to evaluate an individual publication or even more an individual researcher. So not be so proud about the fact that you had a paper published in a high impact journal just because of the impact factor. Just be proud of your paper if you honestly believe that it's a good quality paper. Just be very happy about your work, but not only because it was accepted on a high impact journal. And there are a lot of recommendations in this regard, that just not to use impact factor to evaluate papers and research. I will not go through this. This is the main study that you usually mention. There is also another study I mean, it's not exactly a study, but just a report. There is also another report by the editors of PLOS, I think PLOS Medicine, just showing nearly similar experience. This is just a paper published a few years ago in the Journal of Cell Biology and also in other related journals, Journal of Experimental Medicine and Journal of General Physiology, which are of the same publisher with very closely connected editorial boards, and they just would like to check. They were not so convinced about the impact factor that they received from Thomson, and they just would like to check the numbers. So they asked Thomson Reuters to have at least their raw data. Thomson Reuters provided raw data, which, however, were not coherent, did not support the official results. They spoke with Thomson. They were back speaking with Thomson again, and Thomson told, okay, we just gave you a different database because we have different databases for different purposes. We continue to correct our data. We will give you another database. So in the end, they didn't succeed in reproduce per impact factor. Just to say that this impact factor apparently is not reproducible, but in any case is not subject to an independent audit. You have to believe to the one who calculates the number, and it's a matter of a private agreement. So this was just these are just wolves while barking at the moon, and there are some wolves that ask to each other. So my question is, are we making an impact actually? So I mean, also what to measure to calculate an impact. But there is also an evolution. It's a few years now to evaluate the quality of the individual researchers, we can use the H-index. So most of us, maybe step by step, and most of you already heard or will hear about the H-index, the Hirsch index. Who already knows about the Hirsch index? Maybe we already spoke about in this course. No one? No one heard about the H-index so far? All of you heard, okay. Because if it was no one, maybe it was good, and I would not tell you about this, but I think that it's better to know. So the H-index, it's a few difficult to but maybe not so much. Again, in red, a scientist has an index H. H is just from the name of the one who invented this. He is a physicist, this Jorge Hirsch. This is why H. A scientist has an index H if H of his N papers have at least H citations each, and the other N minus H papers have no more than H citations each. It's a bit complicated, but it's just to say, in this graph, if you put all your papers in a row from the most cited to the least cited, you have an H index of, for instance, let's say 10, if at least 10 of your papers have been cited at least 10 times. So I was clear in this regard. And okay, a lot of limitations. This is all just about citations of individual papers. So it does not take into account the number of authors. You were the only author, so it was just a work with collaborative work with 20 authors has just the same relevance, the same weight. Again, different numbers of citations in different fields. The problem of the position of the author in the list. There are some disciplines, in particular in the biomedical field, in which the position of the author has a significance, and some other fields in which the sequence is alphabetical and so on. It is bounded at the total number of publications. Had Albert Einstein died after publishing his 4 groundbreaking papers in 1905, his H-index would be no more than 5, even if all these papers were cited thousands of times. You understand why? It does not consider the context of citations, gives books the same count as articles, does not account for a lot of confounding factors. We spoke about ghost authorship, guest authorship, ghost writing, etc. It can be manipulated through self-citations and also through many more sophisticated techniques, which now we don't have the time to know, but maybe we will do a course dedicated to how to increase personal bibliometrics. So what's next? It's a lot of things, but I will mention just one thing, just also to reconnect with some bias that Daniele Fanelli told us today. Apparently the main popular novelty in this field is called alt metrics. What is alt metrics? It's a non-traditional metrics. Alt, which in my opinion should mean stop. On the contrary, it means article level metrics. It was proposed in 2010, and now it's increasingly popular. Now a lot of journals, and every day it's an increasing number of journals which increasingly use this alt metrics. And it's article level metrics. It means that it just includes all the citations. Just it's a web-based system that can include with the power of the web-based instruments, which can include any kind of citation in virtually anywhere. This is the badge of the alt metric, and the badge is this donut-shaped. Uses this donut-shaped, donut. Ciambella, shaped visualization, thus to quickly convey information about each article, and you see just that it takes citation from everywhere. So I means the media-induced bias. And this is a kind of feedback, I think, of amplification between all the biases in publication and in the media. The number in the center is the altmetric score, and the colors surrounding the donut reflect the mix of sources mentioning the score. Blue for Twitter, yellow for blogs, red for mainstream media sources, Facebook, red, a lot of very interesting. It's very nice, of course, very attractive. Maybe it also provides you a justification just to spend a lot of time on social media and social networks. And of course, me too, I'm very happy. I try to spend a lot of time on Facebook. And also this course we opened also a page dedicated to this course on Facebook. I don't know with which kind of result. And this is just a comment that last year researchers in the field of physics, Alessandro Ferretti from the University of Turin, which is also a very good friend and is doing a lot also in the field of academic policy. And he has a blog. You see, he has a blog. Very good. You need to think about having your own scientific blog. But he has a blog on a very popular newspaper in Italy, and he published this comment: "You would like to be a successful researcher, so please have a lot of friends on Facebook, have a lot of friends on Twitter, and please think very serious about it. Post your papers." It's exactly what we are doing. When we succeed to publish a paper, we post it on Facebook, and we hope that people will look about it. So, concluding remarks. I don't know about time, but now I will be very quick concluding, and I would just provide you with some hint in this regard. Maybe any one of you heard about Ike and Care? Ike and Care. This is a researcher in the field of informatics, is a highly cited researcher, maybe one of the most cited researchers in the field of informatics, but unfortunately it happens that this researcher does not exist. at all. It was just an invention, just to show what is possible to do on the web and using all these social instruments. I can care. I can care. I can't care. Yeah, you understand it. It was a very nice joke, I think, in this just to show what it may happen if you use only bibliometrics and you do not care. You cannot care about the content of papers. I can care. Another example. You know about Dr. Stronzo Bestiale? I don't know. In English, please. How possible to say? Fucking asshole. Total asshole. Fucking asshole. You're welcome. So, Dr. Asshole, I suppose. And but it's also another famous or infamous episode. But of course, he is still. You can find also this. This is maybe the result. It's a paper published in this very good journal published by Springer, and it's still a paper which is indexed, and in this case it's not a fictitious character. It's possible to say that people who work in the field of physics just maybe know details which are behind this story, and it's possible that it is the result of some conflict among previous collaborating researchers, and so this author decided that the third author, with an affiliation in an Italian university, so maybe people in this field may also understand who is this guy, but they decided that, okay, this author will be just Dr. Stronzo Bestiale, and so we still have this. It's possible to evaluate the bibliometric profile of Stronzo Bestiale. Yeah. Bibliometrics as weapons of mass extraction or mass citation is not it was just the title, also some critical position paper just for criticizing the excessive use of bibliometrics instead of evaluating the content and the results of research. But of course, the H-index is increasingly popular, so all the scientists will look at the H-index, and it's possible also for scientists. It's very funny because it's possible to say that my H-index is bigger than yours, and maybe this just satisfies some of our basic psychological needs. Yeah. And in this case, it's also good for females. You know that according to Freud, females may have some problem in this regard, but not for the H-index. It's the same for males and females. How nice. It's only funny, but this story of citations, this mania for citations, has also some impact itself. For instance, in the budget for universities and for individual researchers. These databases, the main databases, so it's only Thomson's who is allowed to calculate the impact factor. And for instance, in Italy, now I will be not go through so much in these details, but for instance, in Italy, it's only 2 official databases which can be taken to evaluate the bibliometric profile of researchers, which is only the one, Web of Science by Thomson Reuters. I mean, evaluate for what? For the quality of researcher and for the quality of university, officially, by law. So this university is evaluated according to the papers and the citations which are indexed in these databases. Individual researchers, if they would like to have to be recruited, if you would like in the near future to be recruited into university, you need to know, because this is exactly parameters which will be used to evaluate your scientific profile. So how to know? If you are already in university, you will have usually free access to these databases, but only to these databases. If you are not in a university, I don't know, please find a friend, because usually the price is not affordable by an individual person, because, for instance, this university last year paid to access these databases overall about 25,000–30,000 euro. 25,000–40,000 euro just to have access to these citation databases. Of course, it's possible to say that they can be used also for research purposes, but I have some idea that the use for research was not so the main reason to access these databases. All the things that I told you are I'm very sorry for this myself reference, but this is not published in an indexed journal, so at present it does not contribute to my personal citation record, but in any case, what I told you is summarized and maybe is discussed in more detail in this short paper that it happened to me to have the possibility to publish in this web site. Unfortunately, it's still in Italian, and so that's it. I think that we can stop here. I have just to tell you a few additional comments in general about the course, but I will stop here about bibliometrics, and I don't know what time. Okay, so no questions. No questions. I think that this is just what bibliometric is. Just think about it, and no questions, and I will go to conclude also the course in general. So thank you very much to all of you for being still here. And now we will have, no, this we will not look, but why I would like to, why I was thinking about showing this picture, just because one of my favorite movies just remained Matrix for different reasons. But it happens to me to see recently this movie. So what has this to do with research? Maybe apparently nothing. I don't know. Did any one of you already saw this movie? Okay, it's nice. Maybe if you like Tom Cruise, it's nice. And also for guys, it's possible to look, and it's very good. I appreciate it very much, but of course I like science fiction. But just because a few days ago it happened to me to find on the web, on the website of PhD Comics, which I already told you about, this parodia maybe of this movie, which is just the research cycle. Yeah, you read literature, your bibliographic references, write, rinse with a good amount maybe of caffeine in some form, and repeat. So this is the research cycle. So I don't know, maybe it's possible to do some philosophical consideration. In the end, Tom Cruise happens to find a solution and break this circle, and maybe also I hope that with the aid of this course, maybe also young researchers will find some solution to break the circle of biases and of all the problems which affect scientific research, and maybe we happen to develop a good career in the field of research. So that's it. And finally, of course, need to very quickly acknowledge all the people and institutions which allowed to develop and to organize and offer this course. And first of all, I would like to thank all the scientific societies which very quickly and I accepted to give their patronage to this course. There are several scientific societies in several fields of both clinical and preclinical research in the biomedical field. So I think they are not so many, but they represent a significant part of the scientific and clinical research and activity in Italy. And I hope that for now they gave patronage, and maybe in the future it will be possible to involve also these and other societies in this issue of research integrity and responsible research. Some of these organizations also are already deeply concerned with, let's say, honesty in science, and in particular in medicine, which is in particular this association named No Grazie Pago Io, and we had a lecture from one of their representatives. And this course was made possible by first of all, by the University of Insubria. We need to thank several structures in this university, which collaborated to make possible this course. But I would like, first of all, most of all, to tell you about who supported this course. Maybe also this is a part of integrity and transparency in this. And the idea was provided to me by Daniele Fanelli, that first time that, maybe you remember, that first time that we were in touch. One of the questions that you told me, and I was deeply impressed by this, you told me, but which is the support for this course? I mean, it's for profit or non-profit. And I told you it's absolutely non-profit, and maybe it would be a good idea to tell also to all the people which was the money, where it came from, how much and how it was used. And so this is exactly what I would like to tell you in this. And this is actually the last slide. This is the provisional budget. It's not exactly just the final. Let's say this is the raw data that need to be a few clean, but more or less it's exactly this. So the support came all from the University of Insubria, in part in terms of coming from a program which the university has to support summer schools, and which provides usually about 50% of the total budget, and it was 8,300 euro from the program which is called Insubria Summer and Winter Schools. 1,500 came from the Department of Clinical and Experimental Medicine, and about nearly 4,000 came from our Center for Research in Medical Pharmacology. And these are the expenses. As you see, for teaching, it's the lion's share of we paid on average about 80 euro per hour of teaching, plus about 50 euro per hour that the organizing committee spent into organizing the course and all this stuff. So it's nearly 5,000 for this reason. 4,400 for what you had for lunch. I hope that it was good. But I think that this is a voice that in the next time we can try to reduce. Don't worry, we will try to grant the same. And you see all the other expenses. So this is just for transparency, and only institutional funds were used, and nothing else. I hope that this course met your expectations, and also I strongly hope also on behalf of my colleagues that it will be only the first edition. Finally, thanks to the university, thanks to everyone, thanks to the organizers in the Secretariat, and in particular to Mrs. Paola Gervasini that you met in the just outside of this room, and to Dr. Angela Scanzano, who just coordinated the organization together with Mrs. Paola Gervasini. And thanks to the service for video conference and video recording, who provided a lot of support for this course, to all the speakers that are still here and that they are not here, and to all of you, because you were here, and of course this course without you it would not be possible. And now it's finished. That's it.